My name is Brent Eskridge. I'm with the Threat Intel team. Today I just want to provide a short overview of traffic distribution systems. So first of all, why do we care about traffic distribution systems? Well, actors, specifically cyber criminals, have created some massive infrastructures that other security companies just ignore as advertising networks. So some of these, can be hundreds of thousands. So Vigorish Vipers over 300,000. Most of them are in tens to thousands, which is still large. So the challenges with all of those and just the nature of traffic distribution systems, many of those indicators don't end up in security solutions, leaving organizations, vulnerable to these sorts of attacks. And the actors use these traffic distribution systems to specifically target and select victims based on a variety of criteria, which we'll kind of talk a little bit about, and then direct them to content that they weren't looking for. So a lot of the times scams, phishing, malware, we have seen with Vigorish Viper, gambling. So it's not all, the bad stuff we usually think about when we think of stuff on the internet. Some of it's just illegal or unwanted content. So where does DNS come in? Well, as I'll explain, traffic distribution systems have this natural obfuscation just kind of inherent in them. And then cyber criminals really play this up and add more to really hinder research. The great thing about DNS is that it sidesteps a lot of those efforts by cyber criminals to hide the traffic distribution system. So you can't hide from the DNS queries themselves or who has records, even with the anonymization that you can do when you register a domain. And so DNS really lets us look at the traffic distribution system as a whole. We get to see the infrastructure, and we can see it evolve over time and track some of the changes and their reactions to, for example, publications and things like that. So it really allows us to kind of peek behind the curtain. And so then the next question is, why Infoblox? And it's because we have the data to identify and track these massive networks because of our global passive DNS and a lot of other things that we have at our disposal. And then we use that enrichment coupled with our expertise in DNS to identify and track these networks. And so we really can see things that most other security organizations can't see. So let me give you a little bit of an overview about what a traffic distribution system is. So essentially, it manages large flows of traffic. So it filters that incoming traffic according to various criteria that the operator of the TDS sets up, and then will redirect the visitors to some specific location or content. So initially, it was not used for malicious purposes unless you count marketing as malicious. Some of those ads can be pretty annoying, but it was initially set up for marketing, affiliate marketing on the internet to kind of help manage a lot of that. So affiliates, you can see on the image there on the left, the various sources of some traffic to particular web server's content. And so the idea is you can manage that, track that, so see which ad campaign is working the best. If it's affiliates that are sending you traffic, be able to compensate them appropriately based on the volume of the traffic. And so the whole point is that these traffic distribution systems make directing large volumes of traffic easy. Allows you just to set that up and, kind of from a simple console, organize how that traffic is managed. So some of the key uses for these traffic distributions from the perspective of marketers and, threat actors alike. So one, I mentioned that you can manage the flow between different content. It's also been used for A/B testing. So the idea is for like Infoblox, if we have a couple of different versions of a web page or a website, we can redirect visitors, 50% to one and 50% to another to see which gets a better reaction, right? So maybe, the marketing message is a little bit different, so we can kind of test the waters and see which works better. So that's known as A/B testing. And so the idea is you can direct, visitors to one of those two contexts. And also, because I mentioned, there's traffic, affiliate marketing in that traffic, you want to be able to make sure that you're appropriately compensating those who send you traffic, right? And you don't want some sort of bot farm to flood it and then pay them for, not real people visiting, those bots. And so there are mechanisms in the traffic distribution systems to kind of identify the traffic, what's the source, things like that, originally for bots, but you can see, cybercriminals have used it to kind of try and kick out researchers investigating the traffic distribution systems. So as I said, these are legitimate, right? There's a number of legitimate TDS services out there. Keitaro is one of the largest, and we've seen that they've been abused. So VexTrio used Keitaro for a while, but we can see that they're now kind of setting up their own traffic distribution systems. So the idea here is that threat actors have kind of taken TDSs and run with it. So they have scaled up to massive number of domains. So you can see they've kind of taken the model of a bunch of different sources and tracking where it comes from, and then the concept of taking traffic and funneling it to different content depending on criteria, kind of put those together in a blender and then scaled it up, and so you get these massive networks where they can redirect redirect visitors to whatever content they want. So one of the interesting things here is not everything in a traffic distribution system, or not every destination, is malicious, right? So they can redirect visitors to content they just weren't looking for. So it could be an ad, some ads where they just get some profit based on that, or they can redirect to legitimate content like Google. So one of the ideas is, one, just for general, it makes it hard to identify the traffic distribution system as malicious, right? So if I'm just a visitor that got caught up on it, and I go there one time and I go to a bad website, the next time, I just go to something I wasn't really expecting, but it's not bad, I'm not necessarily going to associate it with a malicious intent. And that also goes with investigators, right? So if you're trying to reproduce, oh, hey, one of our users got here and went to a bad site, they could be redirected somewhere completely different. So that randomness and obfuscation is just kind of inherent to the way that cybercriminals have developed these traffic distribution systems and really built them up. So we've already kind of talked to a little bit about the appeal, but what are some of the reasons they went with TDS over others? Well, one, it's a flexible and adaptable infrastructure, right? So if for some reason part of that infrastructure goes down, like a domain was blocked, something like that, they can reroute. Or they have a new affiliate wanting to send users to their content, they can easily incorporate that. And so the operators of these traffic distribution systems essentially act as service providers. So they can sell, a bad guy traffic. And so another cyber criminal will come in and say, I want this kind of traffic, and they can, redirect some of their traffic in the overall traffic distribution system to that affiliate. A lot of this is transparent to the victim or the client coming in. So especially most users aren't really going to pay that much of attention to what's going on. They may see a couple of flashes in that address bar while they're kicked around, kind of like Plinko here, and they're bounced around through the network, but they won't really pay that much of attention. They'll just see, oh, this is the domain I went to where something bad happened, and they may not see that domain again. As I mentioned, it's also easy to hide and obfuscate the destination. So we'll talk about the variety of ways that cybercriminals have implemented traffic distribution systems, but some are a lot stealthier than others. And it takes a lot of intent work to find it, especially with some of the obfuscation attempts. Also, traffic distribution systems. So I mentioned they gather information on the client or victim to try and direct them, but normal traffic distribution systems do that, and cyber criminals have just kind of amped that up, and so they can identify, is this a mobile versus desktop client? Along with that comes the operating system and the browser, right? So I want to redirect traffic to an affiliate because they've specifically requested traffic coming from an iPhone and a Safari browser because they have an exploit or a phishing attempt that looks exactly like an Apple branded alert or something like that. You can also do it on geo IP location. So we saw this a lot with Vigorish Viper. It only works if you're in China, Hong Kong, or Macau. If you're anywhere else, it kicks you out. And even if you try and use VPNs to pretend you're, in one of those places, they have a lot of things in there to try and identify that and kick you out. They can look at the address space. Are you coming from residential or are you coming from a commercial? If they're looking for specific types of victims, they may not even allow commercial traffic in there, right? Because most individuals from their home are not going to have the same type of security precautions that a corporate environment may have. And I already mentioned VPNs. So, and just a reminder, this is a service for affiliates. So, whereas sometimes the operators, the TDS will actually be engaged in malware or phishing. A lot of the times, what they're doing is they're selling this service to others, and so you'll have affiliates both sending traffic to the traffic distribution system, and you'll have affiliates at the other end getting the traffic, and so they want specific types of traffic. And so basically the TDS operators act essentially as a middleman. They operate that network in between, and they pay for traffic that comes in, and then they sell the traffic that goes out. So there's a lot of appeal there, especially for those infrastructure type actors that we focus on and call DNS threat actors. So I've mentioned there's a couple of different types of traffic distribution systems. We're going to focus on three because these are the ones that we've seen most prevalent in some of the data. The first is the normal HTTP-based traffic distribution system. So this is the normal. This is what original TDSs were when affiliate marketing first started creating them. Here at Infoblox, we call threat actors that use this Viper. So this is where VexTrio Viper, Vigorish Viper comes from. So they use HTTP redirects, often with some DNS-based control, but usually it's HTTP redirects. The nice thing from a cyber criminal's perspective is they have a lot of variety they can use for filtering because it's HTTP, so they can serve up a web page that has JavaScript in there that gets a lot of information about the victim's machine. That's where the operating system, browser, that sort of thing they can get that information. So this is kind of the standard one that most people think of when you think of a traffic distribution system in general. We've also seen some threat actors use link shorteners as a traffic distribution system. So we call these Puma. So an example would be Prolific Puma. I'm sure everyone knows what a link shortener is. The idea is URLs are so long, they're difficult to remember, and so you have these shortened links. So one of the appeals, or some of the appeals for threat actors on this are, one, people are accustomed to shortened links. I mean, in cybersecurity, we know not to trust, whatever link, and some of those shortened links, we're not going to click on. But most people have seen enough of them and used them for legitimate purposes, so maybe they're not as apprehensive because they don't see that destination domain. It's hidden behind the link shortener, and that really is an appeal for the threat actor. Now, one of the downsides is they don't necessarily have as much information on the client. So they're still going to web pages, so they may be able to get some of that JavaScript information, but the links are shortened, so they don't have the opportunity to encode as much information in a URL as, let's say, a regular HTTP-based traffic distribution system has. The last one is probably one of the hardest ones to detect, and this is where they use DNS CNAMEs. So CNAME, Seahorse, that's where we get the Seahorse name here at Infoblox. So Savvy Seahorse is an example of this. So what they do is they use DNS CNAME records with low time to live. So the idea is they can constantly refresh this and change it, and the traffic can immediately respond. The downside, as far as the cyber criminal or the threat actor is concerned, is they don't have access to all of that criteria they want to use for filtering. So they only have the requester's IP address. Now, you can get information from that, right? You can try and figure out, is it commercial, residential, where's the geolocation and things like that, but you don't get the wealth of information of the others. On the other hand, it's hidden inside DNS. So when you're redirected through HTTP redirects, sometimes you will see those URLs change in a browser bar. That's not happening here, and so it will be transparent to the client, because how often do you actually look at the DNS queries going through on your home machine inside a browser, right? And so victims won't see this, and so it's a lot harder for the victim to even know that they're a part of one. But as researchers, maybe it's a little bit easier for us once we've said that there's something going on to figure out what's going on, because you can't really hide and there's not as many opportunities to kick someone out of the network. Now, we have seen combinations of these. So we've seen some of the threat actors use more than one. So, for example, I think it was VexTrio has a combination of HTTP and then a few of the CNAME in there as well. Don't know exactly what the rationale for that is, but they've saw fit to combine them. So, it's not necessarily an either or. Sometimes we see combinations of these. So how do we defend against these? So most defenses focus on individual domains, right? So this is the domain the malware came from. This is the domain where we saw the phishing attempt, or this is the lookalike domain, that sort of thing. The challenge with that sort of approach is you're not going to get all of them, especially with something like Vigorish Viper that has over 300,000 domains, right? So as you can see here, you'll catch a couple, but there is still that path to get there. And the threat actors, the operators of the TDS, can just redirect around that block, right? So they just take and change the configuration somewhere to point to a new domain, which makes it really difficult to track. And it, depending on how it's blocked, they can do a variety of things. So if the domain is blocked, we'll just get a new destination domain, right? The people aren't going directly to that domain anyway. They're being redirected there, so it's easy to change that redirect. If it's blocked by URL, well, then they can just go into the TDS and change the way that URL is, and then it's no longer blocked. And if it's content-based blocking, well, they can change the content on that domain and move it to another one. So they have a lot of options for resiliency if you're just blocking individual domains, because that entire infrastructure remains intact. Now, if you instead focus on the infrastructure, which you're able to identify through DNS like we do here at Infoblox, you can see that infrastructure as a whole and block it, right? So the victims won't ever make it to that destination. You've blocked that path through. Now, we'd like to catch all of them, right? But some of them, they're just so large, we're not going to catch every domain, right? We're still finding new Vigorish Viper domains that belong part of the TDS to this day. So we're not going to catch all of them, but the idea is that we've blocked a sufficiently large percentage of them that there is no way for the victims to get to that bad content. And so the challenge here for the threat actors is they can't just go get a new infrastructure. It's easy to get a new destination domain, right? You can go register a couple hundred pretty easy. But when you've got a large infrastructure of tens to hundreds of thousands, you can't just go get new ones and set them up quickly. And so the idea is that we really kind of hobble their entire system by cutting it out at the middle. And the real benefit here is we don't care about the content. We don't care about, oh, we're just blocking this particular malware, or we're blocking this particular phishing attempt. We're blocking everything. So we're blocking all of the different types of attacks, and we're blocking all the affiliates that are using it. So we're not just focusing on one particular threat actor. We kind of get all of them in the package. So some key takeaways here, both for you and to kind of help communicate to others. So first of all, kind of that we've talked about that malicious traffic distribution systems have flourished while they've been dismissed as advertising networks, that, they're not necessarily pleasant, but, it's not bad, right? It's not malicious. We know otherwise, and we're slowly convincing others that is the case. And while, there've been a couple of attempts to block individual domains here and there and things like that, the only way to really do it best is DNS. So DNS can block all of the cybercrime that uses the traffic distribution system, not individual attacks and not individual actors. And then Infoblox is perfectly positioned to identify, track, and block these because, excuse me, we have this unique view with global passive DNS, our ability to enrich that using our expertise and knowledge, and so we can block that entire infrastructure that most security organizations don't even know exist. So thank you for your time. If you have any questions, you can just reach out to Threat Intel.